Hi everybody, I'm Tony E at Show IP Interface Brief, and today is day 70 of the 100 Days of Labbing journey, and I'm getting a late start today because yesterday was my birthday, and I had some house cleaning to do, and well, I'm just taking it easy this weekend. I really need to I really need to step up my game as far as prepping for the CCIE lab. I have about 30 days left to do so, right? As far as the 100 days of labbing goes. So I'm going to step things up into high gear probably just after the holidays. So here we are, middle of November. So probably by end of December, I might even stop streaming and just start keeping track locally for my progress. Just so I can really focus on the topics and the lab and getting good quality studying without any sort of social media distractions and making videos and stuff like that. This has certainly been helpful as part of my journey, so I want to keep it up as long as I can. But I do believe in the near future, towards the end of the holidays, I will probably need to cut this out as well and just focus on the task at hand. And hopefully I'll be rewarded for that with a passed exam. And if not, you know, I understand that most people don't pass their exam on the first try. So, so I'm fully expecting to not pass on the first try and to do better on the second one. You know, to do what most people do, which is buckle down even more and study for test number 2. But if I don't have to take the test again and I can pass it the first time, then all right, I'll take it. So, so today I actually don't want to do one of my long labs like I typically do. Instead, rather, I want to just target a couple of topologies that either I don't know very well or that I slow down on in a lab or I don't know at all. So there's a couple of topics that I have skipped recently in recent labs, and I don't want to get into the habit of just skipping things and moving on for the sake of studying. Instead, I want to use that as the target material to study. So that's what I'm going to focus on today. Today I'm going to focus on multicast. I'm going to focus on MSDP, PPPoE. Every time I see it in the lab, it always slows me down. So I just want to rock it, you know what I mean? I just want to know it inside and out. And so I'm going to spend some time doing some PCAPs, doing some debugs, and really getting intimate with those couple of topics. Multicast is another one that always seems to trip me up, even on basic multicast tasks. So we're going to try a small multicast lab, simple topology, and see what we can do. So I'm going to try and get a lab up. And once I get the lab up, I'll bring the screen over. Let's see. What's my login? I forget my login. So I'm going to do this lab in EvenG. I've been doing a lot of labbing in EvenG. I really enjoy it as a platform just because it has it goes far beyond Cisco and Cisco images. I know GNS3 does as well as of lately, but I'm just a fan of GNS3. You know, I sort of dove in 100%, and I've been enjoying it. So I'm going to pull up a topology. I'm going to go let's see if I can do IOL. I'm going to do a clone real quick, do a rename. We'll call this day 70, and I will move it to another folder. Just getting things started up here. Typically I do all this sort of work ahead of time. Start up labs and build the topologies and everything ahead of time. Let's see, where the hell did my lab go? Uh-oh, maybe something's wrong here. I thought I did open. All right, let me see if I have system status. Oh, okay. I still have a lab running, maybe from last week. Oh, you know what? I don't think I finished the lab from last week, and that's the problem. All right, so let's see if I can start this topology. So I already have one topology running, which is 14 routers, or rather 10 routers and 4 switches, is already running. But I'm getting ready to fire up another lab, which is going to be another 2, 4, 6, 8, 9 devices. So let's see if I don't crash my server here. Let's see if I do these. Start selected. Let's see, I put myself over here. Let's see if I can pop this topology out. All right, looks like those are started. I wonder what our resources look like. This is all on my little home server. And that's not really a server, it's just an old PC that I have ESXi on, so I don't want people to think that I have some monster server in the basement running this stuff. I don't. I have an old PC, and really that's all you need. I know a lot of people out there really are trying to get big beefy servers and hundreds of gigabytes of RAM, and if that's great, if that's what you want, and if you want to support that and you want to be able to say that you have a bunch of servers at home and stuff, but for me, I just want to go as efficient as possible and as minimalist as possible. And so I have 16 gigs of RAM and an old Core i3 processor in that PC downstairs, and it works great. I also run a bunch of other VMs in it, not just Eve. So as you can see, here's my system utilization for this single VM. 86% CPU, a bunch of memory, and I have 9 IOL nodes and 14 QEMU. So these are the Cisco viral images, and these are the IOL images. So today I'm doing the IOL images, and I think I'm just going to sort of draw up a topology to do. So let's bring up a whiteboard. Uh-oh, I hope my pen is working. Uh-oh. Oh no. I think my pen has died. This has happened before, and I wonder where I have the battery. Crap. I don't know if I have the battery. Hang on. This sucks. I was going to draw a topology. Hang on. Let's see. Okie dokie. I have a battery here, so here I have, let's see if we can do a sort of live today. This is the Surface Pro 4 pen. There's probably a lot of videos on how to do this. I hope this is the problem that I'm facing, so we'll see. I think the battery has died inside, so I'm just going to show you how to replace the battery. You grab this end piece here, this section at the end, and give it a little force, and you turn it, and it just turns just a little bit. I don't know if you can see that it has turned a bit. And you should be able to just extract it straight out, just like that. The battery should come with it this way. This is what the inside of that sucker looks like. And so There's the battery. It is a quadruple A, so it is an AA battery, as you can see, I guess, there. And let's see if I can put this in the right way. Last time when my pen died, this is all I had to do. So again, you just match it up so it faces the right way. I got to look at it myself. Wrap the little sleeve around it. I found that sort of helps it slide in. This device was, milled out of metal with really tight tolerances, so everything gets a little bit stuck. You turn it, push it back in, turn it together, and then let's see. Boom, now we're in business. So there you go. Now we can draw. Trash that. I always make sure I have a spare battery with me, but that was my spare. So now I need to order a set of quadruple A's. I have no idea what makes the battery drain. I've had this Surface for 3 years, and I just put in the third battery. So the original battery that came with it burned out. I bought a set of batteries, had 2, and I just burned out the second one. I don't use the pen every day, so I don't know what burns it out, but whatever. All right, so for today's topology, at least for the multicast portion, I think I'm going to do something pretty basic. So we're going to take a router connected to another router, connected to another router, and we're going to do some multicast. So what I want to do is I want to be able to do dense mode, sparse dense mode, and then sparse mode. So we'll do dense mode, sparse dense mode, and then sparse mode, one after another. And so I think for the first one, we're going to have an interface here, and this is going to join a group, and we're going to have this router go ahead and be the source of that multicast traffic. And I think this will be pretty basic. I think what we'll do is we'll also introduce maybe a tunnel, like a GRE tunnel. And then maybe we'll try to influence which way multicast traffic flows. Either sort of steer it over the physical link or over the GRE. And maybe we'll introduce a routing protocol. So again, I'm not really using a book or a guide or anything. I'm just sort of making this up as I go, as I want to explore this protocol, or technology rather. So so what I'll do is I'll make this R1, this R2, and this R3. And I'm going to use the physical topology that I have. So what that means, if I'm using this as my physical topology, it means we're going to use router 1. That green is nice, but I really like red. I'm in love with red. R1, R2, and R3 here. So which means the connection is going to need to go like this, and then another sub interface that goes down like this, which means we're going to have to configure some VLANs on these switches and some trunks and to get this going. And then we'll utilize the rest of this later on for some of the additional protocols we want to work on, or maybe we'll tie them in one larger topology. Okay, so that's what I'm working with there. So we should be booted up. I will need to configure IP addresses on here. No, let me go ahead and do this on all the routers, as it takes a minute after we answer the questionnaire. And let me check the switches. Switches are good. No VLANs, that's good. Check here. No VLANs, all right. So those routers are going to take a minute. So if I try to imagine what VLANs I'm going to use VLAN 12 because that's between router 1 and router 2. And I'm going to utilize VLAN 23 because that's between routers 2 and router 3. And then I guess I'll also use VLAN, maybe I'll use 100 as the LAN interface on router 1. I guess we could just use a loopback as well. So why don't I just use a loopback as well? That'll be fine. So we can get on switch 1. And switch 1, we're going to name our we're going to define our two VLANs, so 12 and 13 and 23. Exit, that should be all we need to do on switch 3, which I think I already have a console open. Switch 3, conf t, we're going to do VLAN 23. That's the only one it needs. Let's do VTP mode transparent, and for switch 1 VTP mode transparent, and that's just so we can see the VLANs in the running config. Okay, router 1, the router should be ready to go now. Interfaces are up. Do show IP interface brief. Let's see what our interface names are. ETH0, I believe, is our connected interface. There it is there on the topology. So let's get into ETH0. We're going to define a sub interface. And because that is our only physical connected interface, so if we ever want to use this interface for anything else, it needs to be a sub interface. So let's just define it now. Interface ETH0. Let's do a no shut. Let's do interface ETH0 .12, encapsulation .1Q12, and IP address 10.1.12.1, and we'll just make that a 24-bit mask. No shut on the sub interface, and off we go. I'm going to turn some music on. And let's also create a loopback one here. So this will be our receiver, our multicast receiver. All right, interface, we'll call it loopback 0, and we'll give it IP address. Man, I love 32-bit loopback addresses. All right, let's hop over to router 2, configure our two interfaces, and you know what? We'll have to put a protocol on here. I wonder what protocol we should use today. Any suggestions out there? What protocol we can use? All right, it's physical interface ETH0, no shut interface ETH0. We'll define subinterface 12, encapsulation .1Q12, IP address 10.1.12.2, and again we'll do 24-bit mask so it matches. No shut and interface ETH00, and we'll do subinterface 23. Encapsulation .1Q23, IP address 10.1.23.2. I always use this sort of IP address schema just because I love it. Krishna, it says IS to IS. Okay, okay, IS to IS it is then. Since you were the first person to comment, why not? IS to IS, I am not very strong in, so actually I'm very glad you said that, because it really gets to test me, because I probably haven't configured IS to IS since I was studying for the CCIE written. IS to IS is on the CCIE written, but it is not in the CCIE lab, route switch lab. I think it is in the service provider lab, but it is not in the route switch lab, so I haven't done it in well over 6 months. So let's give it a try. Sure, why not? Thank you for making the recommendation, and thanks for being on stream with me today. Appreciate it. All right, so here, interface ETH00. We're going to do a no shut on the physical, interface ETH00, 23 for the sub, encapsulation .1Q23, IP address 10.1.23.3, and off you go. All right, so now we need to do a little bit of trunking magic on the switches, and I'm only going to allow out the VLANs I specify because that is often a requirement, and I just want to do it. So let's get on those switches. We'll start with switch 3. Switch 3 only has a single interface. Do show CDP neighbor. Only has a single interface going out to the router. ETH0. So let's get into that interface. ETH00 and do switch port trunk encapsulation.1q. Switch port mode trunk. Switch port trunk allowed VLANs, and we only need 23 to go out to router 3. And switch port non-negotiate. I don't have switch port non-negotiate on here. So I want to try do show interface ETH00 switch port. See, it says negotiation of trunking on. But how do I turn that off on an IOL image? I used to have it on the board behind me. I don't. So switch port mode trunk just defines this side as a trunk. .1q, auto state, include or exclude this port from VLAN, link up calculation, port security private VLAN trunk. So I think the only way to do it is to either do switch port non-negotiate or turn it to access mode. I think is the only ways to do that. So, all right, now let's see what interfaces are between switch 1 and switch 3. Do show CDP neighbors. Between switch 1 is ETH1 and 2. Okay, so let's do exit interface range. Interface range ETH1, 2 to 3. And let's make this a port ether channel. And so let's do PAGP. Channel group, and this is between 1 and 3, so we'll do 13. Mode, we'll make this side initiate. Channel group desirable. Actually, I always sort of fall victim to this. I'm going to do no channel group 13. And in fact, what if I do no interface port 13? See what that does. All right, I want to hit the range again. I want to do switch port trunk encapsulation.1q, switch port mode trunk, switch port trunk allowed VLAN 23. I only need 23 over that trunk. Now I want to do channel group 13, and I want to do mode desirable. So that port channel should now become a trunk. So show run interface port channel 13. It's a switch port. Okay, okay, okay. How about if we do interface port channel 13, switch port trunk encapsulation .1q, switch port mode trunk, switch port trunk allowed VLAN 23, no shut and show interface trunk. I don't see the port channel in this list. I messed something up. Is the port channel down? Show IP interface brief. Port channel is up. Show run interface. Port channel 13. It's a switch port. Okay. Trunk encapsulation. Trunk allowed VLAN 23. Switch port mode trunk. I feel like I'm missing something. Let me hop on switch 1. Do the configs on this side. And see how we end up. So 1, 2, and 3. Interface. 1, 2 to 3. Excuse me, interface range. Switch port. Trunk encapsulation. .1Q. Switch port. Mode trunk. Switch port trunk allowed VLAN 23. No shut. Channel group 13 mode auto. Okay, creating port channel 13. Change state to down. It should bounce them. Should come back up. All right, those interfaces are up. Then I should see the port channel come up and the port channel up. Now, when I do show interface trunk, I see it there. All right, mode on, perfect. 802.1Q, it's trunking, yes, yes. And it's not forwarding yet. There we are. All right, 23. Let's hop back to switch 3 and see what's the deal. All right, port channel 23, perfect. All right, so we also got to finish up our trunking to our router interfaces. So here we'll do show CDP neighbor. And actually, I kind of want to cover these up just so I'm relying on the configs and not the diagram. All right, going out to R1 and R2. Because both of these need the same config, wait a second. The port to switch to router 2 needs a different one, okay. Interface 00. We can do switch port, trunk encapsulation .1Q, switch port mode trunk, switch port trunk allowed VLAN 12, no shut interface. What was the other one for router 2? 01, ETH 01, switch port trunk encapsulation .1Q. You have to define an encapsulation because if not, it will negotiate to ISL. Switch port mode trunk, switch port trunk allowed VLANs 12 and 23. No shut end. Hey Krishna, it says, may I request a thing? You can request something, sure. I don't know if I can answer, if I can do it, but you can always ask. And if I can, then I will. So yeah, go ahead. You can just post it in the chat, and I'll see it when I look over. All right. So now, if I stand up a routing protocol, I should have reachability. So Krishna requested ISIS, so let's see what we can do for ISIS. We shouldn't need anything to do with our switches anymore. So let's just get up on router 1, which is over here, and router 2. Which is here. I'm trying to remember how to stand up the damn IS to IS. I'm telling you, it's been a long time, and even I wasn't a pro at it. I did it just enough to learn the basics. So let's do router ISIS. I think the routing area tag is optional. I think we do need to define a I thought we needed to define an area, but maybe I'm not thinking of it right. I thought so. Maybe it is the... Let me see what IS type. So this is going to be, let's see, level 1, they all have to be in the same area. Level 2, they all have to be in different areas. And level 1 and 2, they can talk between areas. Okay. So I guess let's make this one. What I'm wondering is I wonder if I should do router 1 as level 1, router 2, which is in between routers 1 and 3, as level 1 and 2, and then level 2, router 3 is level 2 only. I guess we can do. I guess let's just do a level 1 only for now. I don't want to get too stuck on this. So then if I find my interfaces, do show IP interface brief. I think not router, IP. What is it? ISIS. What do I have to do here? I thought I needed to put like router something. There, IP router, ISIS. I didn't define a tag, so I'm just going to hit enter. I think also under the routing process, I need to define like an area. Router ISIS. Area password. Something, some sort of ID. I'm going to leave almost all of these to default. I thought we had to define an area, or what is it called? Address family, an area password authentication. Something ID? What is that thing called? Oh, net. Okay, network entity title. All right, net. Here we go. 49, and we'll call this area 1231. And then oh, you know what? I think we can do it like this for our routers. Is that too many? I forget. Let's see. Looks good. All right, so our area is going to be 1231. That's what I was looking for. All right, also, I want the loopback interface. Let's see what Krishna's saying over here. I saw your blog as well. You don't post much on it regularly. That's true. It would be great if you could make your labbing projects, not INE or proprietary, into a blog post, including what you did during the stream. Topics covered, topology, screenshots, configs, and your tips and tricks. I agree 100%, Krishna. Thank you for recognizing that. And thank you for asking for that, because that is my intention. It's not my intention at this stream or at this moment, but after I pass my CCIE, it is my intention to sort of go back through and sort of build labs like this for others to do, and to be able to provide help topics and tips and tricks and stuff like that. And believe me, I'm no expert, but sometimes it's even more beneficial to learn from someone and to learn from their failures. And I definitely try to expose that a little bit. You know, I certainly am not successful all the time. So I hope that I can document that process with blogs, with topologies, with labs, screenshots and configs, just like you defined, and be able to offer those up in a package, you know, for each one, each topology or each lab that I do or something like that. It takes a lot of time to make that kind of material. I started this journey a long time ago, sort of doing exactly that, building labs, building topologies, and making topics for people to lab along with me. And it took a lot of time to be able to keep up with that and try to focus on my studies. So unfortunately, I had to cut out a couple of the things that I was doing so I could spend more time studying. And one of the things I had to cut out was updating my blog and building labs for others to keep along with me. So that's why I've been spending a lot of time in the INE workbook or other proprietary materials, because if anyone wants to lab with me, by all means, they can go buy the book. I realize there's a cost associated with that, but they can buy the book and they can lab along with me, and we can all learn together. But unfortunately, it takes a lot of time to be able to do that, so I can't do it at the moment, but I will be doing that soon. And by soon, I mean after I pass my CCIE, I want to be able to hand out and pass out sort of any lab topics or tips and tricks and things that I've learned along the way, and in hopes that that helps others, and not just for CCIE, but for anyone in CCNA or CCNP, to be able to sort of cover those topics. Because another way to describe, I mean, having me describe topics, I know a lot of technologies and protocols are covered very well by other vendors and other things, but having someone else explain them is sometimes beneficial. You know, that's why there's so many vendors out there covering the same material, because each person learns different, and each person sort of likes an instructor, you know, or prefers an instructor over another. And so I feel like the more people out there, the more opportunities people have to learn from others. So I intend on doing that. It will be a little while down the road, but thank you for pointing that out. I hope that answers your question a little bit, and I hope that when I do get to publish some materials, you'll be one of the first people to grab them. So thanks for asking for that, because it really helps to motivate me into making sure that I stick to releasing some materials. Thanks. So with this ISIS, I need to configure it here on router 2, and then I should have an adjacency. So this is going to be type. No, what do we call it? ID type? No. What do we call it? Network type? IS type. Okay. IS type. We were going to do level 1. Which means we're going to share an area. Oh, but you know what? I should have... that means we're going to share an area, but I should have changed this. So let me see if I can change this, actually. I might have to bounce this... router process, yeah. Okay. Alright, so I'm going to do no router ISIS. and then do router ISIS, IS type, level 1, and then see if I can use this network entity title. I'll likely need to configure the interface as well again. Show IP protocols. Alright, so I need to configure that on an interface. That's going to be show IP interface brief. And just to verify, do show run interface. Okay, conf t interface ETH00, subinterface 12, and this is going to be IP router ISIS. Now I'll need to do the same here. I wanted to see, do show IP protocols. Yes, so now that I've defined it on an interface, now the router sees it as an active protocol. So let's get into our sub interface and IP router ISIS, and we should see an adjacency. Let's wait just a moment. I don't know what the timers are on ISIS. At least I can't recall. Let's make sure the protocol is on. Okay, it's going out the right interface. I'm troubleshooting this a little bit. Show ISIS neighbors. Oh, good. All right, I do see a neighbor, and you know, ISIS is actually something I haven't explored a lot. I tried to learn the basics on what I could to stand it up, which is, I'm not going too far beyond that here, but the basics to stand it up as needed to pass the written exam. So now I'm just going to sort of explore a little bit. Not running in OSI mode, only calculating IP routes. Okay. Alright, the metric to get to router 1 is 10. The next hop is towards router 1. This is the egress interface. And this is going to be, I guess, the MAC address probably of router 1. Okay, so let's configure it. Since we have the protocol running, interface ETH00 on the other sub-interface, which is 23, and do IP router ISIS. That should turn it on that interface. If we do show IP IS interface. Show IP ISIS. Maybe it's just I'm hoping to see the interfaces. I guess show IP protocols is how we're going to see those interfaces, just to make sure it's activated on those interfaces. Hang on, I got to set this fan up. Okay, now on to router 3. So I think once we get this IS to IS stood up on router 3, we'll be good to go. Okay, so let's do router ISIS. I'm giving it no tag. IS type, we're going to go level 1, which means they all share an area number. Net 49, we're calling it 1231. And this is router 3, so let's go 3333. 33333. Now our Ethernet interface. So interface ETH00, and we know the sub interface is 23. IP router ISIS. Show IP protocols. ISIS is on for that interface. Show ISIS neighbors. All right, we're seeing router 2. So we should be able to see the link now. Oh, Krishna, losing connection. My local ISP sucks. I'm sorry to hear that, man. But I'm glad you get to hang out and stick with me for as much as you can today. I won't be going too late today streaming, as I'm doing a part of my birthday celebration today. But thanks for hanging out with me, and thanks for giving me the good suggestions. In case you can't stay very long. Okay, so from router 3, I should be able to see I should have a route to the link between routers 1 and 2. So show IP route, and I do. Here it is, ISIS. It's a level 1 route. Perfect. Okay. Also, I want to include the loopback interface on router 1. So show IP interface brief. It's loopback 0. It's up. So let's do config T router ISIS. And let's do passive interface loopback 0. Now I think that will advertise it. Yeah, there it is. So by defining that passive interface, it's just something that I've always remembered. That actually, I'm trying to remember his name. Rohit Pardasani, one of the INE instructors. I took a class from him and he taught me. And it was one of those things that I didn't fully understand. I just knew that when you did that, that happened. Which is defining the passive interface on a loopback. It advertises it into the protocol. Alright, so now we have that set up. We should have full reachability, so I'm going to go ahead and do a ping test. Ping 10, 1, 23, 3, which is router 3, and I'm going to source it from loopback 0, and boom, we have connectivity. So now I'll go ahead and start the multicast, what I want to do for multicast. So I guess I need to think about what sort of requirements I want to have for multicast. Okay, so for multicast, the only requirement I set out was I wanted to do dense mode, sparse dense mode, and then sparse mode. So for dense mode, I think we can just turn on LDP between our interfaces. We don't need a rendezvous point. And as long as I source some traffic from I guess router 1 or router 2. Excuse me, I guess we'll source it from router 3. And we'll make the loopback on router 1 the receiver, the multicast receiver. So, let's see if we have a multicast routing. Show show IP multicast, I think. Multicast routing is disabled. Number of multicast boundaries configured this route. Okay, so let's do config T and do IP multicast routing. Enter. We'll just go around the board. IP multicast routing enable, and conf T IP multicast routing enable. Okay. I don't really deal with multicast very often, so this lab will probably be fairly simple as far as multicast goes. And I don't have any complex requirements because I don't really deploy multicast. I think it's a pretty cool technology, but there's So many things to tweak with timers and IGMP and LDP and all this other stuff. It's maddening for me. Okay, so for our interfaces, I want to do I'm trying to recall subinterface 12. So let's do like IP, not LDP, IP. What is it? IP PIM. Oh my gosh, I can't believe I said LDP earlier. IP PIM. Let's do dense mode. Enter. And on our interfaces, ETH00, 12, IP PIM, dense mode. Interface, ETH 23. Looks like PIM. DR change from 0 to itself. PIM neighbor up, okay. And DR change from 1 to 2. So it looks like it's choosing the highest IP address. And so let's do IP PIM dense mode. And here it's going to select itself as the DR, right? And then the interface ETH00 23, IP PIM dense mode. All right. So now it's going to change from itself to 2, and then this is going to change from, or rather from itself to 3, and this is going to change from 2 to 3, because now it's going to select the highest numeric IP address on the link as the DR, the PIM DR. Okay, so now this is going to be like a flood and prune sort of topology. And in the past, I've had some issues with IOL images and multicast, or rather with IGMP snooping. So let me see. Show IP IGMP snooping. IGMP snooping is enabled. And I assume it is here as well because they're the same image, just different host names. Show IP, IGMP, snooping. It's enabled as well. So actually, I want to leave it on for now, and I want to see if I can make this work. On R1, I want to end conft interface loopback 0. IP, IGMP, join multicast group. What do we always do? Something easy. 239.1111. Now I think I need to turn PIM on that interface. Let me do show IP IGMP interface loopback 0. Let me see what's up with that. Loopback 0 is up, line up. Internet address. IGMP is enabled. IGMP host version. Router version. Okay, show IP PIM interface. So I guess from router 3, I can try and do ping 239. And it worked. Okay. So I guess in between, show IP multicast is enabled. Multicast interface. All right, so on this is just a cool, interesting show output. On the interface between 2 and 3, we have packets in, out, so one packet in, and on the interface between routers 1 and 2, one packet out. That's because we sent only a single multicast packet. show IP im route. So this is saying for any source going to this multicast group, if I'm trying to read it sort of out loud to my, well, to all of you, but to myself as well. So any source, which is star comma G, to this group, our outgoing interface. That's interesting that it's both interfaces. And from this source to this group, our incoming is the interface between router 2 and 3. Understood. The reverse path forwarding neighbor. Okay, it's 3. And our outgoing interface is the interface between routers 1 and 2. And that's forwarding and dense mode. So let me see. Show IP IGMP groups. Now if I do here, show IP IGMP groups. Yeah, they're all joined to that 224.0.1.40, and that's for that. I think it's the sparse dense mode. I think this is for the sparse dense mode. Gosh, I remember watching the INE videos when I was studying for the written and trying to make copious notes about multicast, and now I can't quite remember much of it. Which is why I want to do these labs. So I guess this is sort of a basic multicast, and right now I just kind of want to explore some show commands, just so I can get used to the output, so I can understand what the different fields are, and so I can more efficiently and more quickly recognize what I'm looking at. So show IP PIM interfaces. This is our local IP address on this interface that has PIM activated, PIM version 2, I guess dense mode. There's one neighbor on the link. Our query interval is 30. DR priority is 1. And the DR is router 2. So I wonder if I can change that DR, which is on interface. IP PIM. DR priority. And that is a large number. Preference given to a larger value. Okay, so now it changed from 2 to 1. And I don't think that will affect our multicast traffic at all. No, that's still working. Show IP im route. This one, show IP im route. And this one, show IP im route. So it looks like for the S comma G, right, the source comma G, the outgoing interface is null, and that makes sense because we're receiving it on router 1. Let's see, a plant-based brother. I love that name. I'm working on my my CCIE. routing and switching. Thanks for tuning into the stream today. I really appreciate it. Let me know if you have any questions. I'll try to answer them. Right now, I'm just sort of exploring multicast. Probably not at an expert level. Multicast is not something I do very often. So for me, I'm kind of just taking the basics approach and exploring some show commands and stuff like that. So let me know if you have any questions. I'll try to answer them. I just kind of want to implement sort of the 3 different modes of multicast and make sure I understand the requirements and what the show output looks like. And then I'm going to spread my topology out, maybe introduce some other other protocols, maybe PPPoE I wanted to do, and MSDP. So we'll see. Thanks for tuning in. All right, so if we do sparse dense mode, we gotta have a. I think if we don't have a rendezvous point, it will be flooded as dense mode. Is that the correct understanding? I tell you what, let me change the PIM. Let's keep our same setup and change the PIM mode to sparse dense. So interface ETH0012 IP PIM sparse dense. I kind of want to see how that affects the neighboring router, see what router 2 thinks, if they change their neighborship or anything. It might be a 30-second wait timer, I think. So I'll kind of get ready for the change over here. 0012 IP PIM sparse dense. I didn't see a change here, so let me just hit that. And we'll do the other sparse dense. We'll come over here and conf t interface ETH0023 IP PIM sparse dense. So now if we do show IP PIM interfaces, will that work? Okay, so now we see the same here, right? PIM version 2, sparse dense under the mode. Hang on a second. I'm back. Krishna, I have to check the upload again. Missing key bits on live. Hey, yeah, the live stream will be uploaded, or it's YouTube keeps it up there forever. So I hope you can scroll back through and catch what you miss. I just had to take that phone call. It's my birthday weekend, so I had having some interruptions. And I'm getting some text messages and stuff. Hey, that's the way it is, man. You know, when you're studying, whether it's CCNA, CCNP, CCIE, when you're studying, you know, life doesn't stop and wait for you. You know, you just gotta roll with the punches, and you have interruptions, and family comes, and you know, you just gotta deal with it. It is what it is, and that's how it is. All right, so we just changed from dense mode to sparse dense mode. We can verify it. Whoops. We can verify it here. I know I got tons of crazy stuff, bunch of projects going on. Do show IP PIM interfaces. So we can verify our interfaces are sparse dense mode, PIM version 2, show IP PIM interfaces. And you know, as boring as watching someone do a bunch of show commands is, it is very important, I have found, in the CCIE practices that I've you know, been involved with. You know, verification, man, you can miss something. You could just miss one command on something and lose points for that entire section. So verification is very important. So definitely, if you have the time, take the time to do it. Now, I want to see if my pings will still work and what version they're using. So I did not define a rendezvous point yet. I think that is a requirement for sparse mode. I think if we don't have a rendezvous point defined, it will use dense mode to flood. So let's see. 239.1111. Okay, we see one reply. Let's do repeat 100. Okay, here we'll do show IP mroute. And look, I'm seeing it as forwarding as sparse dense mode. I think that's very interesting. Maybe that's just the mode of the interface it's forwarding, or maybe it's forwarding via sparse dense mode. Okay, that worked pretty good. So, I tell you what I'm gonna do. I guess I'm gonna. I wonder if I can. All right, so I guess on router 2, I want to define a rendezvous point and then see how this changes things. I tell you what I'll do on the 3 routers. I'll change their mode to sparse mode only, and then try the multicast ping again, which I believe will fail. Then I'll try to define the rendezvous point and see if I can remember all of the steps needed for that. And then we'll try the ping again, and hopefully we'll be successful. And then I have a couple other things I want to implement. So far this has been a pretty good lesson. A lesson for myself. I hope anyone watching has any. I hope it has some value for you as well. And again, if you have any questions, feel free to pop them in the chat, and I'll try to answer them as I can. Okay, so interface ETH0, 0, 12, and we're going to do IPPIM sparse mode. Conf interface ETH0, 12, IPPIM spar. Config interface PIM IP PIM. I'm not in an interface. That's okay. That's no problem. Sparse mode. Okay, so now if I do show IP PIM interfaces, I'm going to see I'm running PIM version 2 still, and now it's sparse mode only. The DR on the link is 3, which is router 3 because it has the highest numerical IP, because they both start off with a designated router priority of 1. So if I do show IP PIM neighbor, I should see the neighbor there, the interface it's going out of, and I want to try and break these down. The designated router priority is 1. And let me get to this text message. Okay. And let's see what S, state refresh capable, P, proxy capable, and G, gen ID capable. Wait, this looks like mode. That looks like some mode values. Okay, so I guess it is proxy, state, and gen ID capable. Alright, so now show IP PIM interfaces. Okay, sparse mode. Show IP PIM neighbor. Alright, remember we set the DR priority on router 1, so that works. Show IP PIM interfaces. We just want to verify we're sparse mode all around. Now here I'm going to ping 239.1111. Yeah, I expected that to fail because it should be trying to reach out for a rendezvous point. So let's on router 2 configure a rendezvous point. So I think we can configure a static rendezvous point. I think we can configure a static rendezvous point. Let's do loopback 0 on router 2. Called IP address 2222 and a 32-bit mask, and we'll define this as the rendezvous point. So exit router ISIS, passive interface loopback 0. There is our loopback advertised. So on router 2, I believe we have to define the rendezvous point as well. So I'm going to do a static rendezvous point configuration on routers 3 and 1. IP PIM RP address 2222. Oh, look, it says, okay, wait a second. PIM 6 invalid rendezvous point join received. Join from invalid for 2222. Line protocol tunnel 0. Change state to up. Right, I'm going to configure the same here. IP PIM rendezvous point address 2222. should see the same error messages again. Okay, tunnel up. Okay, I just want to verify. Okay, PIM, invalid rendezvous point registration. Received register from router 3 for this group. 2222 not willing to be rendezvous point. I think that's kind of funny. Very sort of passive. I think, you know what I'll do? Go ahead and grab a screenshot of that because I think it's funny. I'll just keep that over here. Okay. So I think what I want to do is on router 2, I also want to define IP PIM rendezvous point address. I think I want to define it. And what I'm wondering is do I have to include the rendezvous point in PIM? So if I do like do show IP PIM interfaces, I don't have the rendezvous point in here. So let's try the ping again. Nothing. Yeah, so I think we have to do interface loopback 0, IP PIM sparse mode. And we see BIM DR changed from 0 to 2. Okay, that's on the loopback interface. Now if we do show IP PIM rendezvous point, I think there is a rendezvous point. Enter. All right, for this group, the rendezvous point is 2222. PIM version 2. Now. So these are our tunnel interfaces. Okay, let me get on these switches just to see. I'm turning off IGMP snooping on the switches because in the past, with the images that I'm using, it has given me some problems, mostly related to like the all nodes and all routers multicast address. And so I just want to make sure that I'm not battling a lab problem, something that's incorrect here with the images this lab. Okay, so I thought we can statically configure the rendezvous point. Do show IP IGMP group. All right, this is so now I need to explore a little bit. So I thought we could statically assign the rendezvous point, like without issues. I'm forgetting something and I don't know what it is. I haven't done multicast in a while, and I certainly don't do it at all. It's going to be for all groups. Show, I'm trying to figure out, how do I figure out who's registered? Show IP PIM. Auto RP is enabled. Rendezvous point discovery packet MTU is 0. 40 is joined. Last time I did this, I blew up the damn router. So let's see what happens. I'll just go ahead and put that in the let's see. All right, I want to ping that again. Ping. I didn't really see it. Okay. Show PM route. I didn't even see it leave. Debug IP packet. Okay, destination, local feature, okay, source, destination, length, sending, multicast, output feature, force false, send cell false, sending full packet. Okay, so here's when we did send source, Destination received. Should be length 58. What is the length here? It says length 100. Wait, source. Okay, so this is a PIM. So this is going to PIM. So when we source it from the interface and it goes to the PIM multicast address, which is that 13. The length is 54. I think the actual ping was 100 bytes. Okay, so let me add 2 commands here on what I'm calling the rendezvous point router, router 2. I really thought we could statically assign the rendezvous point, and I'm not sure why that's not working for me. Okay. RP candidate loopback 0. Try it one more time. I wonder if let me see switch 3. I was just thinking maybe the packets aren't going across the port channel, but I feel like they must. Oops. Show interface trunk. They couldn't be going anywhere else, could they? I don't know. I guess perhaps they could. Alright, so this is one of those times where I'm going to have to go look it up. So I'm just looking up configuring a rendezvous point. I'll go ahead and throw it in the chat window. This is what I'm looking at right now. I don't know if it's a good link or not, just taking a look myself. Yeah, rendezvous point is required only in networks running PIM sparse mode, which we are. This method of delivering multicast data is in contrast to dense mode. Is flood to all segments of the network. Routers have no downstream neighbors. Or direct connected receivers prune the unwanted traffic. Okay, wait a second. Sparse dense mode for auto RP, right? Auto rendezvous point with multiple rendezvous point scenario. Bootstrap router. All right, I'm looking at the configs there. All right, let me see the bootstrap router. Okay, everything's in sparse mode. Okay, multicast routing, see PIM sparse mode. A rendezvous point. Where is that rendezvous point anyway? It's got to be on one of the routers as a loopback. Yeah, I mean, I feel like that's what I have here. Maybe I'm missing something. Let me do a do show run interface loopback 0. Do show run include PIM. This looks like a good document with some good examples in it. However, I'm not finding. I have to just back it up a bit. Let me check out this link. I'm just taking a look at these configuration examples. I'm reading over the screen here. I think I have a new link. Show IDP. Yeah, I mean that's what here, I'm reading this one now too. I'll post it in the chat. I feel like I'm doing I got all the right moves. Just can't groove, I guess. Let me take out this rendezvous point candidate. Show IP PIM interfaces. Do show IP PIM interfaces. All right, I get the loop back. PIM sparse mode, neighbor count. That's good. That's good. That's good. Show IP PIM interfaces just to make sure. And R1. Show IP PIM interfaces. So mtrace, source to trace route from. Okay, our source 111, destination of route.
This is the same old crap over and over again.
Oh, all right. I'll tell you what. Let me do this. Mtrace source is 10.1.23.3. Destination and 23.9.111. I wonder how to interpret this output. Mtrace definitely not something I've used before. Okay. Maybe he's not joined. Show IP IGMP groups. 239.1.1.1 is still joined. Let's try this. Ping 239. So why can't routers 2 and 3 show IP PIM neighbors? They see each other. Okay, everything looks good, but I cannot get router 3, or rather router 1 to receive some multicast traffic from router 3. I thought I turned IGMP snooping off on switch 3. Okay, this is tough stuff. because everything looks right. All right, so I guess let me try the bootstrap router. I'm looking at the blog post by Roger Perkin. We use a similar, just looking at his topology here, we're using a similar IP routing schema. So server and client, okay, he's got 6 routers. Router 2 will be the rendezvous point, okay, very similar to what I have. Show IP PIM interface. All right, I don't have my loop. I don't have fucking PIM turned on that interface. CompT interface loopback 0 IP PIM sparse mode. Okay. DR change on the local loopback, so that's no big deal. Alright, so I wonder if that was the only thing I was missing. This should work. Oh my god. Oh my god. You gotta be kidding me. Wow. Unbelievable. Unbelievable. Okay, so that is a lesson to be learned. Let's throw open a fresh notepad. I'm trying to think how to make these notes worthwhile. Configured. I'm a terrible typer, so you guys are watching me misspell everything. Normally, you know, that's why we use Google and Microsoft Word and Word processors that can autocorrect for us, because I'm freaking terrible at typing. Oh, I just saw Denise Fishburne reply to my tweet earlier from, well, it's just the auto tweet from YouTube announcing my stream. So I tell you what, she's the queen of multicast. I definitely could have used a quick lesson from her today. Probably her lessons are, I would have solved this problem much earlier had I watched more of them. If anyone wants to go watch some Denise Fishburne videos, she's got an awesome YouTube channel, as well as a lot of videos over on Cisco Live. Let's see if I can find her YouTube channel here. No. No. Gosh, she's got a ton of videos on YouTube. I can't find her channel. But definitely worth watching. She's often doing teaching classes on multicast, and I definitely could have used some good tips. I didn't know she had one. Yes, she's got an awesome channel. If you get on YouTube, you can find all of her videos, but definitely subscribe to her channel. You won't regret it, man. She's posting some good material. And she also teaches classes at Cisco Live, not just here in the U.S., but around the world. So, and anyone can register for Cisco Live's website. Go on CiscoLive.com, register for, create an account, and you have access to the entire library of talks and classes and videos and all kinds of stuff. So there is more information there than I think you could spend a lifetime watching. On just about every topic that Cisco has a product for. So, and definitely she teaches the multicast classes there. So, all right, and RP must be configured either statically or dynamically. Are there two L's in that? I don't know. The receiver must have PIM turned on to receive traffic. Now I want to say dense mode the receiver, and I don't know if this is just my lab or is this all the way around. The receiver does not have to have PIM on its destination interface. I don't know if that makes sense. And I think on sparse dense mode the same. Which maybe there's something else going on that that I'm not recognizing. So let's do static, which is IP PIM RP address. Even the rendezvous point must have the static rendezvous point must have the static rendezvous point address command. And PIM turned on for its rendezvous point interface. So that was very unique. So that's with the static rendezvous point. So now I want to sort of branch out into the auto RP as well as the bootstrap router. So it'll take me a little while, but I'm just trying to make sense of what we've done so far, right? The receiver must have PIM turned on to receive traffic. The receiver does not have to have PIM turned on its destination interface. All right, so let me send a couple more pings through, and then I want to check the multicast routing table, the imroute table. So let's send this through, and let's do a repeat 100. And also, let's just get these geared up so we can check the multicast tables. Okay, that's working. So show IP imroute. Okay, here's our star comma G, which is going to come from any source to this group. Our outgoing interface is the interface facing between routers 1 and 2. It's sparse mode, it's forwarding, it's good. Now for this specific source, so S comma G, for this group and this source, incoming interface, right, the interface between routers 2 and 3, a reverse path forwarding neighbor is router 3, outgoing interface Again, same as above. Sparse mode looks good. And then let's see what we see here. Show IP in route. So it sees it as the source, which is the actual source and the group. And the outgoing interface is the damn loopback. And that's very interesting. And let's look at these flags. LJT. Scroll up a little bit, take a look at the flag. So local, J is a join, shortest path tree, and T is the shortest path tree bit has been set. Let's take a look at the star comma G is sparse, join the shortest path tree, local, and what is C? Connected. Oh, and it's showing our rendezvous point here. And for here's our rendezvous point. Okay. Just kind of wanted to see what it looks like from the router that's sourcing the traffic. So none of the routers actually know where the multicast traffic is ending up. I guess we need to get like all the way down to the end of the line. In this case, it's router 1 and do a show IP IGMP group, maybe. Membership. Okay. Okay, so I think I can flip this and do auto RP next, and then I'll move on to bootstrap router. So this is a lot to consume. There's a lot of nuances in dealing with multicast, such as the flag identifiers. I need to get used to reading those. I need to get used to reading the show IP mroute list. We haven't even gone through like a reverse path forwarding or static mroutes yet. Again, I'm just trying to more comfortably familiarize myself with some of the show output and some of the configurations. So, excuse me. I think I'm going to take just a quick water break, step up from the chair for a minute, stretch my back, and I'll be right back to annoy all of you in just a few minutes. All right, and we're back. Whew. Okay. Where was I? Let's see. We just finished up static rendezvous point configuration with multicast over a very simple topology. And so that's pretty cool. Just trying to get a good refresher because I always find myself stalling out when it comes to multicast. So it's a little chilly here at home, but I guess we're ready to start auto rendezvous point. Auto rendezvous point will oh, let me see. Get the cameras. All screwy here. Auto rendezvous point. We will do. We got to change from sparse mode to sparse dense mode for auto rendezvous point, and there's some other configuration elements we got to hit. So let's dive right in. We're working with the same topology, so nothing different there. And let's dive into the lab. So for that, first thing we got to do is we got to change our interfaces. So let's start off with show IP PIM interfaces. And these are going to be our two interfaces that are participating in PIM. Interface loopback 0, IP PIM sparse dense. Interface, you could just do a quick copy and paste. IP PIM sparse dense. Okay. Show IP PIM interfaces. Conf T interface, we can do loopback 0, IP PIM sparse dense. Interface, copy and paste. Copy and paste again. Interface, copy and paste. And copy and paste again. And we'll work over here, show IP, PIM, interfaces. So we're just grabbing, identifying what interfaces are participating in PIM via the show IP PIM interfaces command, and then moving that over to sparse dense mode as opposed to just sparse mode. So if we do show IP PIM interfaces, we should see here SD as the mode, show IP PIM interfaces, SD across the board, perfect, and show IP PIM interfaces. Excellent. Hey Paul, how's it going, man? Hey Tony. Glad you could join me on stream today. Glad to have you. Just working on some multicast, getting ready to dive into auto RP with multicast. Just trying to explore some of my weaker topics, so I don't get slowed down by them when I do my larger labs. You know I still have room to grow on the protocols, EIGRP, OSPF, a lot of knobs to turn there, but I'm not even where I need to be in the basics when it comes to multicast and a couple other topics. So just sort of taking some time out, nice and slow, learning what I can. Also did a good troubleshooting session earlier, right? I didn't get something working, so definitely exposed some of my weakness there, and this will be very exciting if we can get through this today. So thanks for joining me on stream. All right, so it looks like we have everything in sparse dense mode. We have the static rendezvous point configured, so let's unconfigure that. We'll do a show run, include RP hyphen, and we'll just do a conf t no paste enter, conf t no paste enter. We know everyone has this configured across the board, so no paste enter. All right, so now we do not have a rendezvous point set at all. Do show IP PIM RP, and we get nothing. Okay, so now let's define on our rendezvous point. Let's tell it is the rendezvous point candidate. So IPPIM RP candidate. Wait, let me take a look at the PIM show command. Excuse me, the PIM configuration commands. Okay, so for this one, I believe we have to do, we got to set the candidate. And then we have to do our announce and discovery. I'm just looking at the commands, just trying to familiarize myself with what the options are. IPPIM, RP candidate, and I think we do an interface, don't we? So that should be loopback 0. And if we hit enter, that should become our candidate. Next, IPPIM send RP announce. Okay, scope time to live for the rendezvous point announce packet. Since our routers are only one router away, I guess let's call it, we'll call it 2. 2 hops, and we'll hit enter. We'll also do IPPIM send so I don't actually know if I need to set the discovery. I don't actually know. Let's see what happens. I'm trying to send a ping packet, so that ping is still working. So now let's do show IP PIM RP enter. I get nothing. That's strange. Is it like flooding via dense? Sparse dense? Sparse dense? Oh, okay. And scope 2. Alright, so let's see. Show IP, PIM, RP. That was deflating. So okay, I have the 2 neighbors. Oh, okay, wait a second. Tunnel up. Tunnel up. I don't remember seeing the tunnel go down, to tell you the truth. So let's see what's up with that. Show IP PIM RP enter. Okay, so now I have a rendezvous point. I have a rendezvous point for the group 23. Excuse me, 239.1111. I think I said 4 ones. Version 1, version 2. Next rendezvous point reachable in 1 minute. Show IP PIM rendezvous point. Got nothing there. Show IP PIM rendezvous point. Okay. I do have something there. show IP PIM rendezvous point. Okay, so the sender of the multicast traffic is not going to see the rendezvous point until it has multicast traffic to send. Then it registers with the rendezvous point. What I'm. Right, so like when this expires, we should lose it completely. Which is going to be what, in 2 minutes? I just see the counter counting down. I'm kind of waiting for it to bump back up, so maybe that's a 3-minute timer? And I don't know what this next RP reachable in. It's different than the receiver and the sender. So what I wanted to do was, sort of as we explore through this, I also want to add in a tunnel, just a regular GRE tunnel that goes between routers 1 and 3, which should have a better metric, but should break the reverse path forwarding. So I've been through multicast labs where that's typically one of the exercises, and it's to get your mind thinking about, sometimes you need to force the reverse path forwarding check to validate a route or a path that is less preferred. Alright, so I wanted to see what the... Alright, so it looks like it was probably a 3-minute timer and that somehow it started over again. I wonder when it expires. And this says like version 2 straight up. And this says version 2 version 1. This says version 2 version 1. Alright, show IP, PIM, RP, mapping? Let's just say. Okay. I'm going to try and do a PCAP here. Just kind of want to take a peek at what that looks like. If I pull up router 3, try to send one ping across, we'll see what happens. So the layer 2 destination is the multicast address space. I was looking to see if it was any of that traffic was going to be tunneled. So I tell you what, let's see if we can maybe GRE. I don't see anything. All right, let's try auto RP. So the source, okay, UDP. Looks like the only difference between these two is actually 1 bit. Between the mapping and the announcement is 1 bit. And if I try to pick out the timings, between the mapping is 19 and 80, so I'm going to say that's 60 seconds. Or no, because mapping again is at 140, which is, which is 60. No. It is 60, okay. Looks like every 60 seconds. And then for the announcement, 23 to 83 is 60 seconds. And 83 to 43 is 60 seconds. Okay. All right, cool. So I guess what we'll do is I guess what we'll do is we'll move over to Bootstrap Router. I'm wondering if Auto RP and Bootstrap Router can coexist, either on the same router or within the maybe just like within the same segments. Maybe that'll be a fun lab to do a different time when I'm a little bit more well versed in multicast. All right, so let's do Bootstrap Router. If I'm trying to recall off the top of my head, I guess you know what I'll do is, before I move on, let me pull it like the example, show run include RP. I'll just do that. For my notes. All right, sparse dense mode. Sparse dense mode, we can do auto RP. It says the receiver does not have to have PIM on its destination, was my note from earlier. Tell you what, let's test that. On the rendezvous point. Uh-oh. Participating. Oh my god. Participating. All participating. PIM interfaces include RP. All right, so let's take PIM off of show IP PIM interfaces. Let's take PIM off of loopback 0. And see if the ping still works. All right, so he's still joined to the multicast group. Let's see if that still works. Okay, it does still work. Well, I'm wondering if that's sort of a side effect of the timers. Like maybe something hasn't timed out yet. All right, so let me review the notes. Sparse dense mode. Auto RP. The receiver does not have to have. I tell you what, let me just take that damn interface down. Interface ETH00, and then we'll see. We'll shut it down. The receiver does not have to have PIM on its destination interface. Let's see. On the rendezvous point, all participating PIM interfaces, including the rendezvous point, interface. Static. And what was it? IP PIM sparse mode. I put global for global config and interface. All right, so I think for sparse mode, we can also do, here I'm just trying to think, boot, strap, router, trying to figure out a good way to sort of organize these notes. I think typing the notes sort of helps. So I'll no shut that interface sort of while I was typing. And then I want to try the pings again and see if they're going to work. All right, so it does work. It says the receiver does not have to have PIM on its destination interface. And I don't know if that's just sort of this image specific or this lab specific or what. But I'm getting good multicast pings. Oh, wait a second. That stopped. Let's see what happens if we do it again. All right, nothing. So now on interface loopback 0, IP PIM, sparse dense mode, hit it. So I wonder why I got those replies early on up top. But I know I'm getting them now. How about I put, when using static RP. And I'm not 100% that's true yet. Still needs some more testing. But I want to put it on there. All right, so now let's see if we can convert this to a Bootstrap router. So again, let's leave router 2 as the rendezvous point. Let's change our interfaces in show IP PIM interfaces. Let's change the interfaces from sparse dense to sparse mode only. IP PIM sparse mode interface. Copy paste IP PIM. Alright, sparse mode and show IP PIM interfaces. Sparse mode, good. See, I know I got a loopback 0 in here. IP PIM sparse mode. Do show IP PIM interfaces. So I gotta grab these two guys. Interface paste IP PIM. I was mistyping this. And interface. Copy paste IP PIM. Do show IP PIM interfaces. Alright, 3 sparse mode interfaces. Now router 3, show IP PIM interfaces. Got the single interface. It's going to be the origin of our multicast traffic. IP PIM sparse mode. Show IP PIM interface. Alright, so now we can take out a couple of commands we have in here. Do show, run, include RP. I think we can take these out. We're going to the global config, no, paste, no paste. Also going to do this, no paste. Now, I don't remember all of them, right? Because I'm trying to do a refresher here of everything I need. I'm trying to sit up straight. It's kind of like awkward for me to sit up straight. It hurts. My back hurts all the time, so I got this like funky position I'm working on here. All right. So let's do. IP PIM, Bootstrap router candidate. That's going to be our loopback 0. I'm going to hit enter. IP PIM. I'm looking at the options here, I'm reading over them, trying to remember Is there nothing else I need to do? No, there must be something. I can't remember what it is. I'm looking at these options here, and I don't remember what I'm supposed to do. Okay, so let's do show IP PIM rendezvous point. Is that right? Show IP PIM rendezvous point. It says rendezvous point 0. That's not right. Show IP PIM rendezvous point. All right, bootstrap router. PIM bootstrap router. IP PIM. I tell you what, let me see if I can. So this is in sparse mode. Okay, so we know this ping should not work. A multicast ping should not work at this stage, I think. Let's send it. Nothing. We'll send it again just in case we got a timing or connectivity issue. Okay. All right, let's try IP PIM. RP candidate. I mean, I feel like I've already done this, but I know it's not in my config, but I know I did this for the auto RP, and I thought they were two different configurations. So let's see, show IP PIM rendezvous point. Now it has a rendezvous point. Show IP PIM rendezvous point. Now it has a rendezvous point. Show IP PIM rendezvous point. Now it has a rendezvous point. Now let's try to ping. And it worky. Alright, so now that we got this working, I guess it is working. Let's do the show IP mroute and take a look at what we have here. Show IP mroute. Incoming interface, outgoing interface. And T means shortest path tree. Where is that? Shortest path tree bit is set. And this show IP mroute. All right, interesting multicast problems we have today. All right, so I guess what I'm going to do is show IP route. I guess I can build a GRE tunnel between routers 1 and 3. And see if that breaks anything. So for router 1, okay, so let's just do conf t interface tunnel. We'll call it 13, and we'll call it IP address 10 13 13 1. 24-bit mask is fine. Tunnel source eth00 slash subinterface 12. Tunnel dest is going to be 10 1 23 3. Protocol is up, so let's do conf t interface tunnel 13, IP address 10 13 13 1, 255 255 0. 2 ends. Tunnel source eth00 23. Tunnel dest is going to be 10 1 12 10 1 12 dot 1. Should get a tunnel up, and then let's see if we can do ping 10 13 13. Cool. All right, show IP route. So I think we can do, I don't actually know if I could run ISIS through a GRE tunnel. Well, at least I've never done it. But I suspect we just turn it on the interface and let it ride and see what happens. But what I'm expecting is that the 1111, the quad 1 loopback on router 1 from router 3's perspective will have a metric value of 10 instead of 20. And I want to see if that breaks anything. So config interface tunnel 13. Yeah, crap. I wonder if under router ISIS there's like a log adjacency changes. That's what the hell I want. Ah, crap. Router ISIS log adjacency changes, and then under interface tunnel 13, I want to do no IP router ISIS. We should see it fall over, I would think. Do show ISIS interfaces. How about do show IP protocol? Alright, ISIS protocols on 13. I don't know why I don't see the adjacency changes. Show ISIS neighbors. Router 2 is still the neighbor. Maybe that's why. And show IP protocols. Show ISIS neighbors. Nope, still only one neighbor. But I wonder why. I wonder why that doesn't work. For GRE. I'm gonna look it up over here. ISIS GRE. Okay, let me try this again. You know, when you search just blindly in something for ISIS, it always ends up throwing, you know, ISIS-related material, and it just sucks. You know, you're trying to look up protocol information, and you get bombarded with a bunch of news articles that are unrelated to protocols. So I'm just looking up if I can I'm just looking at a bug here. I'm on the Cisco website. It wants me to log in. I'm just not going to do it right now. Let's see about the support forums. If I find a good link, I'll share it in the chat. Issue. Tunnel GRE connectivity is there. Let's see the neighbor over the tunnel interface. Sometimes the forums are very helpful, and sometimes they're not, but it's always worth reading it just to see if you have similar problems, similar issues. It's been a pretty good source of information for me over the years. I'm not finding what I need here. Configuring ISIS over GRE. Getting a whole lot of nope. Just in my search results, I'm not getting anything that stands out. I'm getting a couple of Juniper articles, which may probably help my overall understanding, but are not going to help me configure. Maybe an MTU issue is maybe what we can find. All right, so I tell you what, maybe ISIS isn't the way to go for this, so let's just throw some OSPF in that sucker. No trouble. Just for the sake of moving on, interface tunnel 13, IP OSPF 1, area 0. Come on, buddy. Conf T interface tunnel 13, IP OSPF 1, area 0. IP OSPF interface brief. What's going on here? Show IP OSPF neighbors. Nothing. Point to points, no trouble. Show IP OSPF interface tunnel 13. I mean, looks good here, right? Network type point to point. State is point to point. Show IP OSPF interface tunnel 13. Hello and dead 1040. What's going on here? I think I'm going to go back to Wireshark. Just capture right here on this egress interface, and see if OSPF is getting encapsulated in GRE. I gotta find out why I can't get. I can send pings across GRE, but I can't get a protocol. Hello. Here's a packet. All right. GRE. OSPF is going across there. Alright, so I tell you what, let's just go grab some OSPF. So it looks like hellos are being exchanged both ways. Wait a second. Wait, the source is always... The source is always router 1. This is weird. Wait a second. The physical IPv4 address is flip-flopping, right? Because we're sending and receiving. But the OSPF packet is always being sourced from 13.1, which means I might have the same IP address. Show IP interface brief. I have the same fucking IP address on both routers. What an awesome troubleshooting experience this was. Show IP interface brief. Look at that. Same IP address on both. And now, so I wonder if that is the source of my problem with ISIS. So let's do conft interface tunnel 13 and go no IP OSPF1 area 0. I'm just going to take OSPF off for a moment. Conft interface tunnel 13 no IP OSPF1 area 0. And let's change the IP address. IP address 10.13133. Show IP interface brief. Look, I got a CLNS. Adjacency change. Tunnel up. Okie dokie. Now we're in business. Okay. Adjacency parent. Mid-chain parent maintenance for IP. Mid-chain out of tunnel 13. Looped chain attempting to stack. That is some crazy topology verbiage that I am not familiar with. I don't know what that syslog message is telling me. Yeah, so I don't know why it's bouncing. Let's see. I think it's recognizing that there's a loop. I'm trying to understand what the loop is. So here's, to get to this space, here we go, tunnel down. So we're tunneling to this as our destination, and it's seeing it via the tunnel. That's the problem. And so it's trying to get to the tunnel destination via the tunnel. Okay, so how can we do that? I wonder how I can apply some sort of filter. All right. It is always disruptive to have an interruption while you're trying to troubleshoot something. Okay, so obviously I have a loop. Okay, the loop makes sense. How can I prevent the loop? I'd like to do some sort of route filtering, but I'm not sure if I can do that. So let's do interface, tunnel 13. IP router. All right, let's try it from router ISIS. Maybe I turn off that capture without saving. All right, how can we do filtering? I just want to see if I can apply it via an interface. So maybe distribute list. Okay, we can. I think distribute list. Let's see if we can do like prefix. I'll just give it a bogus prefix list name. Okay, and then do gateway. Yeah. And the gateway needs to be a prefix list too. Okay, inbound. And I can do a. Alright, awesome. Okay. So let's define two prefix lists. One will define the neighbor, one will define the prefix, and we'll stop exchanging that prefix over the tunnel, which should solve our loop. Alright, this is always fun stuff. So we're trying to see kind of to IP prefix list. I'm going to call it 12. I'm going to do prefix list 12. Deny. From router 3, okay. 10, 1, 12, 0, /24. IP prefix list 12 permit. Let me do sequence 1000 permit less than or equal to 32. And then IP prefix, I'm going to call it 13 and permit 10, 13, 13, 1. Alright, so now let's do router ISIS. Distribute list. We're going to call it a prefix. Then we want to do the prefix list of 12. We want to do it from the prefix list of 13. We want to do it in tunnel 13. Okay. IP prefix list, I'm going to do 23. Bless me. Prefix list 13. Deny 10, 1, 23, 0, /24. IP prefix list 23, sequence 1000, permit quad 0, 0, less than or equal to 32, and then IP prefix list 13, permit 10, 3, 3, 3. /32. Router ISIS. Distribute list. Prefix 23. Gateway 13. In tunnel 13. Yeah, so the loop back should be the only thing I'm learning through the tunnel. And the 12 space, I'm learning via router 2. Okay, so filtering is working as expected. JP route. The 23 I'm learning from the router 2. Should be nothing I'm learning from this space. Unless I put a loop back on here. Okay, unbelievable. Wow. I guess I don't know if this is actually going to make any difference, the tunnel. Unless I do create a loopback on router 3, I think. So let's do interface loopback 0. IP address 3333. IP PIM. Sparse mode. And then router ISIS. Passive interface loopback 0. So from router 1's perspective, it should have a preferred path because of metric through tunnel to the quad 3. Okay, it does. So which means when I ping 1111 and I source from 2333, it's going to be using the tunnel. So now when I try to ping 239 can I source from 2333? I don't know if that's actually going to work. So that ping, that multicast traffic, I don't think should be sent over the tunnel because the tunnel's not participating in PIM. So let's go ahead and pull up Wireshark, take a look. We're going to be checking for encapsulation. All right, router 3. Let's set that ping again. Okay. Let's take a look at some of this. Just stop it right here before it goes off screen. Okay, it's being sourced from, and it's an ICMP. Oh, wait, I see it being sent once via the physical and once via the GRE. This is a PIM register message going from my physical interface to the rendezvous point. Hang on, I got someone at the door. Okie dokie. All right, so, oh my gosh, it's freezing here. At least I'm freezing. You know, like I was saying, you know, hey, interruptions happen. You know, when they happen, you just gotta roll with it. That's just the way it is sometimes. Yeah, pick right back up where you belong. Let's see. The PIM message. Oh. I think that is actually the tunnel, right? This register message. Look, it's completely encapsulated, right? So that's our egress interface to the rendezvous point. I expand this a bit. Let's see, I think we should see PIM in here. Protocol 103 is for PIM. So as far as layer 3 is concerned, it's a PIM packet. Here's the register to it, PIM options. It's carrying IPv4. But I believe this is the tunnel. And so it's actually tunneling the payload. Right? This is our echo request. It's actually tunneling the payload. And I want to see what this next packet is. This is going straight up from our loopback to the group. So same as that. And that's not going out the tunnel. And then our replies are coming from our GRE. Both are coming through the GRE. Okay. I'm trying to follow along here. I would have thought maybe that wouldn't have worked. Let me think about why that's working, so I can try to think about what I need to do to make it not work. Right? Trying to break it. So I guess if I source it from gosh, I don't know. How the heck can I do this? Let's grab router 3 and let's do the same ping, but let's source it from the other interface. Oh, the multicast ping. So 10.123.3. We're receiving 2 replies. Why do you suppose that is? Oh, I have my capture off. Alright, let's do one more capture. I gotta get packed up soon. I won't be on much longer because it's my birthday weekend and I have an event planned for this afternoon. So when my family returns, I'll be getting offline. And now I got a single message. Okay, let's stop it. That was a single message. Ping is going out from our physical interface to the multicast group. Ping is going out from our physical interface. It's going out the GRE as well. I didn't think we turned PIM on that sucker. And then the replies coming straight back over the physical and our registration is coming back. All right, let me check the GRE here. Show IP PIM interfaces. It's not on the GRE, but it's being sent anyways. That's Okay, what do we want to take care of next? So we've sort of done static RP, auto RP, bootstrap router. We've stepped through that configuration. Let's check the notes. That's auto RP at the bottom there. Sparse mode, bootstrap router, also static RP, and dense mode. Okay. So I guess what I'll do is I'll try to do PPPoE next. I'll do PPPoE between router 4 and router 3, and that'll probably wrap it up. So that means I need to add a sub interface here. Interface ETH00. I'm going to call it 34. Encapsulation.1q 34. IP address 10.1.34.3. Okay, let's get the switch up here. Show CDP neighbors. I'm trying to do this lightning fast. Switch port trunk allowed VLAN add 34. And then also I have no idea what interface this is. Would you like to enter initial configuration? No. We'll let that cook. Switch 3, we know we do need to add a VLAN. VLAN 34, no name. And while we're waiting on router 4, while we're waiting on router 4, on router 3 we can begin to configure the PPPoE server. So here's BBA, PPPoE, and global. You can give it a name here. Global will be fine. And then we'll use a virtual template. We'll call this one 34 between routers 3 and 4. Enter, exit. Interface, virtual template. 34. IP address, IP unnumbered ETH00.34. What else do I need? I kind of forget. I mean, this is exactly why I wanted to do this exercise, because I just flat out can't remember. Router 4, conft interface ETH00, no shut interface ETH00.34, encapsulation.1q 34, IP address 10.1.34.4, 24-bit mask, no shut. And now let's get on to switch 3 again. Do show CDP neighbors. Let me see router 4. Interface here. Switch port. Trunk encapsulation. .1q switch port. Mode trunk. Switch port. Trunk. Allowed. VLAN 34. No shut and alright, ping 10.1.34.3. Show IP interface brief 10.1.34.4. Encapsulation .1Q34 is good. 24-bit mask is good. Router 3. Do show run interface ETH00. 34. .1Q34. There's 3. Okay. Do ping 10.1.34.4. Alright. We are up. So here, interface ETH00.34. Here we're going to do PPPoE. Enable group global. All right, router 4. Interface dialer 34, obviously. Dialer pool 34. IP unnumbered interface, nope, E00.34. PPPoE, excuse me, PPP, encapsulation PPP. I almost don't know even, like, why this is even on the exam. I don't know. I bet there's thousands of people out there who deal with PPPoE all the time. It's just not something I see, so I have to question it. I wanted to see accession. Show one client session, show PPPoE summary. Okay. Alright, so I'll tell you what, let's pull up Wireshark and see if I have a PPP encapsulation. Then I'll wrap this up. Alright, let's see. Yeah, so here's the echo request, echo reply, echo request, echo reply. Should be 5 times. And you can see here in the protocol pane, it's PPP encapsulation. That sits right behind the 802.1q encapsulation. So PPP is ready to go. Thank you. So I guess we scroll down through here. We see the pings encapsulated in PPP versus going out the plain sub interface. So that rocks. So I guess that was really truly like one of the most minimalist configs you can do, right? There really wasn't much to it, and a lot of times most of the labs that we do have much more to them than this. So I'm going to just close down the Wireshark here. And make that a wrap. I got to get ready to go. So thanks everyone, and I'll see everybody next time.